In this video, I would like to explain about the algorithm that we can use for the text classification. Okay, for the text classification algorithm, we usually call it as the classifier. Okay, a text classifier labels the unstructured text into predefined text categories. So it means we have the text, okay, and the text is unstructured. And we are going to predict this one into some kind of categories. Okay? And it learns to classify the text based on the previous observations. So we call this is the observation or examples or the corpus. Okay? Sometimes we call it corpus. And typically using training data for pre-label examples. So we already have the label to indicate about the categories. The algorithm, which is the main machine learning process, is also known as classifier. Okay, so the word algorithm classifier can be used, and in a classifier, it is a hypothesis. Hypothesis means something with we want to analyze, or it can be also a discrete value function for assigning the categorical class labels to specific data points. So the common algorithm or the classifier we can learn in this case is the naive Bayes. So the naive Bayes, we will learn about the multinomial naive Bayes, Bernoulli naive Bayes, and also the logistic regression. This is an example of corpus. So given 5 sentences in the corpus with the corresponding categories. So this is the categories. And let's say this is the text or this is the corpus. We want to classify whether it is related to sports or not sports. So let's use an algorithm to classify whether there is a new text, a very close game. It belongs to sports or not sports. So we call this is the training set. Let's say a great game. Okay, it is sport. The election was over. Oh, okay, this is not sport. Very clean match. Okay, this is sports. A clean but forgettable game. Oh, this is related to sports. It was a close election. Okay, this is not sports. Then if there is a new text, okay, a very close game, can you specify what would be the best category for this one? In this case, yeah, we can deal with some kind of probability. If it belongs to sport, okay, given that a very close game text, so what is the probability? And even I want to know the probability if it is not sport given this text. Okay. So yeah, in this case, we will look at the probability. If this probability is higher than this one, then yeah, it belongs to sport. If the probability of not sport is higher, then it belongs to not sport. So we need to calculate it and we need to confirm about this one. Now we have the previous text and we can make this kind of matrix. So a great game, yeah, the metric is like this one, a great game. The election was over. The election was over, okay, and very clean match, okay, very clean match, clean but forgettable game, game, yeah, and then clean but forgettable, and so on. So with this information, then we can have a binary vector representation. So this is the binary vector representation. And each of this binary, it represents the word. For example, this is about A, this is great, this is game, and so on. And this is the category. So if we have the new text or the new sentence, then we can also create the binary vector representation. So this is the binary vector representation for the new word. Then we can look at the probability. Okay. So the probability of spots, we have 1, 2, 3. So 3 out of 5 data, or 0.6 is it belongs to spot, and 0.4 or 2 over 5 it belongs to not spots. Okay. So naive Bayes is a probabilistic algorithm based on the Bayes theorem. So this is the Bayes theorem, and yeah, we are going to look at the details when we do with this probability. Means I want to know the probability of A given B. So the probability of B given A multiplied by the probability A divided by the probability B. It is naive because it ignores the prior distribution of parameters. So there is no prior distribution of parameters. So I do not know whether it is high or not, but just based on the probability. And it assumes the independence of all features and all rows. Okay, so this is very important. That's why they call it as naive. So the presence of one feature does not affect the presence of another, which may not be true in practice. So for example, if we have the probability spots and then given the text a very close game, so it means I can know that what is the probability that this text appears given that the category is spot, and I can multiply with the probability of spot and divide it by the probability of very close game. Okay. So using this idea, let's look at back to the frequency. Okay. So the multinomial naive Bayes, we call the multinomial naive Bayes. It is a Bayesian family with the frequency. So we can make the category spot and not spots. If it is related to sport, so this is the frequency. So there are 2A, 1 grade, two games, very clean match, but forgettable. Okay. And if it is related with the not sport, okay, so the A is only 1, there are 2, the election, and so on, like this one. So we have the frequency for each of the category. Now, based on the naive Bayes, we want to look at the probability. So the word means a very close game, and I want to know whether it is about spots or not. So if we calculate this one, it means I want to know how many word count in spots and divided by the total word count in spots. So this is the basic probability. And of course, there are a lot of zero. Okay, zero, zero, zero. Because of this zero, last class we already learned about the smoothing. You still remember about the smoothing? Yeah, we have the variant at 1 smoothing, at k smoothing, or we can use the back off. Okay. Or we can use the interpolation smoothing. So this is the variant of the smoothing. Okay. And yeah, we can apply them. Let's say I'm going to use the at 1 smoothing. Okay, so we call this is the Laplace smoothing. With the Laplace smoothing, we want to make sure that every zero there is still possibility. Okay, if the word count in the spot is 0, okay, so we will add by 1. So there is a small possibility that there will be 0, and we will need to add the v. V is the number of the unique words. So this applies Laplace at one smoothing to avoid 0. The total word count, yeah, we have 8 and 7, 8 for spots and 7 for not spots. So yeah, this kind of variance, it might be a little bit different between some of the algorithm. For example, some algorithms, they want to look at the intersection, okay, or some of algorithm, they want to just look at the categories of this the word on those categories and so on. Okay, so let me use that the total word count, okay, in this case for sports there are 8. Okay, 1 2 3 4 5 6 7 8, and for not sports we have 7. 1 2 3 4 5 6 7. Okay, and the vocabulary size in this case they are 14, so it is total. Okay, 1 2 3 4 5 6 7 8 9 10 11 12 13 and 14. So using these numbers, okay, we can calculate. We have the a given spots. So what does it mean? It means that I want to know the word a and it belongs to spots. Okay. So you can see there are 2, okay, and 2 of them among 8, okay, among 8 of this data, it belongs to the spots, and then yeah, we're adding with 1 with 14. So 1, it is for the Laplace, and the v is the vocabulary size. So here we have the probability, yeah, 3 divided by 22. So the thing here is we can also calculate with other word, for example, grid. Okay. So grid, it is 1, okay, plus 1 divided by 8 plus 14. Okay. So this is for the spot. What about if A not spots? So A for A, this one, and this is for not spot. The not spot has 7 total word count. So we put this formula and then we can get the value 0.095. What about if we have the word was? The word was here, then it means 0 plus 1 divided by, because it is belong to spot, and it is 8 plus 14. And it is 1 divided by 22. Okay, so this is how we can overcome the 0. Okay, if there is 0, then we can use this Laplace. Okay, so we have that one. We have the probability for each of these word, and we plot into this table. Okay, so spots and the word and this is the probability for grid. This is the probability for game. This is the probability, and so on. Okay, so I didn't put this one. I hope that you can understand that this is with the Laplace. It means that yeah, you can have the numbers. Okay, so you can calculate the number by yourself, and we can calculate the posterior probability. The posterior probability means that if we have spots given the sentence. Okay, so it means I want to know if it is sports. Okay, if it is sport given the word a very close game. Okay, then it means I want to know what is the probability of sports, which is 0.6. Okay, we know from the previous one there are 3 out of 5 data they are sports. And then a very close game. So I want to know the probability of that it belongs to sport. So this one is 0.0136. And what about if we have the vary and sports? Okay. So vary and sport. So this is the probability. And what about close to spot? Okay, close to spot. Okay, this is 0. So as you can see, 1 divided by 22. So it will be about 0.045. So this is the result. And game spot. Okay, game given spot. So this is the probability. Then you can multiply all those more probability, and then you will get the value. Yeah, this 0.000000384. We can also do with the not sports. When we have the not sports given the sentence, then again we will do the multiplication of not sports multiplied by the probability of A belong to not sports multiplied by the P, which is vary belongs to not sport, the probability of close belongs to not sport, and the game belongs to not sport. So this is from the word a very close game. So this is the new text that we want to predict. Okay. Based on this one, okay, this is the probability, and the result is this probability. So with this multiplication, okay, with this multiplication in this posterior probability based on the naive bias, what is the decision? Because the probability in sports is higher than the probability of not sports, then the sentence is classified as sports. So the sentence a very close game. Okay, the sentence very close game, it belongs to sports based on the probability. So we choose the highest probability. Now let's look at the Bernoulli naive bias. So the Bernoulli naive bias is another variant of the naive bias, but it is a simplification of the multinomial naive bias. In a Bernoulli naive bias, we just use the binary features. It means whether a word appears or not. So in the category sports, if it appears, then it is 1. If it is not there, then it is 0. So if it does not appear, 0. If it appears, 1. Okay. So we can do this one again with the probability. So we will calculate the word presence count in sports plus 1. Okay, so we again use the Laplace smoothing. And the total sports document plus 2. So plus 2, it is just giving more value in order to make this number higher. Okay. So it is not related with the number of the word again, because if we use the number of word, it will be very high. But if we just use the number of document, or it is about the number of categories, then yeah, we just plus 2 in order to make it a little bit higher. It is because all the numbers will be only the binary. So this, yeah, there of course there will be some other variant. You can mention that this one, can we change to the number of class? Yes, this is also okay. So if the number of class is 2, then you can put 2, okay. Or can we put the number of class plus 1? Okay. So if the number of class is 2, and then yeah, you want to put as 2 plus 1, yeah, that's also possible. So anyway, this is a number that you can increase, okay, in order to avoid a small value here. For example, if the value is very small, like 1, then the probability will be very high. So in order to avoid the high probability of this one, so we need to put some values, or yeah, we put the values to make it a higher value for this denominator. And if it is higher, then the probability will be a little bit lower. So let's say if I want to know the probability of A, okay, so in the sports, because there is axis A, so we just put the plus 1 and divided by the total sports document. So there are 3. Okay? The previously we have 5 corpus, and 3 of them is sports and 2 of them is not sports. So there are 3 documents plus 2. So the total is, yeah, the probability of A in the sports is 0.4. What about game and sports? You know that game, there is 1 plus 1 and divided by 3 plus 2, so 0.4. What about A and not sports? So if it is A and not sport, A is available in not sport, okay? And there are 2 documents of not sports, so 2 plus 2, then the probability is 0.5. Okay, so this is the probability with the 1. So whenever the word exists, so it is available. If the word does not exist, so you can calculate by yourself. Okay, what is the probability? The probability means 0 plus 1 divided by, yeah, if it is sport, then 3 plus 2. So the probability will be 1/5. For the not sport, it means it will be 0 plus 1 divided by 2 plus 2. Okay, so the probability will be 1/4. Okay, so this will be for every 0 here, and 1/5 it will be for every 0 in the spot. Then we can also again calculate the posterior probability. In this case, the posterior probability, again, I want to know whether it belongs to sports given the sentence. So the sentence, we have a very close game. Then we can calculate it. Belong to sports. Okay, so what is the probability? Is 0.4. Very belong to sport. This is 0.4. Close. Okay, nothing here. So we calculate, before we calculate 0 plus 1 divided by 3 plus 2. Okay, then it is 1/5. 1/5 is 0.2. So 0.2 we put here. And then game sports, it is 0.4. Okay, so we got the probability 0.0768. And again, we calculate the not sport given the sentence. So we put all the values like this one. Okay, you can know from the values in this matrix. And after we have this one, we can look at the probability. So based on the probability, this is 0.007, this is 0.006. Then yeah, the probability of spots given the sentence is higher than the probability of not spots given the sentence. So the sentence is classified as spots. Okay. We have another algorithm, we call it logistic regression. Okay. So logistic regression is widely used for binary classification. So this is mostly for binary classification. For example, yeah, you can classify whether it is spam or not spam. Yeah. So the model will be based on the probability using the logistic or sigmoid function. Okay. What is the sigmoid function? We can take a look on this formula. So the logistic or the sigmoid function is like this one. In the denominator, it is 1 plus e minus beta 0 plus beta 1 multiplied by x1, beta 2 multiplied by x2, plus and so on. And in the denominator, we have 1. So 1 divided by this logistic or the, yeah, we call this is the logistic or sigmoid function. It is the c given the x. So the logistic regression learns the weights or coefficient for each feature word to predict whether a sentence belongs to sport or not sport. So for every word, we will make it as a feature. So for example, this is the feature that we generate from the previous table, from the previous matrix. So this is the first sentence, this is the second sentence, third sentence, fourth sentence, and fifth sentence. So if you look at the previous one, yeah, this one, okay. Based on this feature extraction, we can make the binary factor representation. So we can make this one as an x. Okay. And for this calculation, we need to have a y. Y means the target. The target, yeah, if it is sport, then let's make it 1. If it is not sport, let's make it 0. Okay, so 1, 1, 0. So 1 means sport and 0 means not sport. Yeah, I do not want to make it complicated. Okay. In logistic regression, when we try to make the weight, usually we use some methods like SGD, stochastic gradient descent, or yeah, maybe there's also another way to get the weight. So let's just assume that we train the model and we got the following weight. So let's say this is the weight. So the A have the weight 0.2 and the word grid has the weight 0.5. The word Kim has the weight 0.8. The weight for the is minus. So there's a possibility to have minus. If it is positive, we can say, okay, it has an effect. Okay. If it is minus, then it has less effect, or it has a negative effect. If it is lower value, maybe the effect is not that high compared to the, yeah, this one. Kim is high and election is something like in the minus. Then we can have like an idea if it is in the average 0, then if it is higher than 0, maybe it belongs to the class 1. If it is lower than 0, it belongs to the other class, or the class 0. Okay. So let's say we have the intercept, or the theta is 0.1. So theta means like the beta 0. Okay, the beta 0 is the intercept, and we have the word a very close game. Oh, I already have this one. So we can calculate, okay, the beta or the z. It is based on the beta 0 plus all the sigma. This is based on this one. Okay, it is based on this one. Beta 0 plus beta 1 x1, beta 2 x2, and so on. So we can calculate it. If it is, yeah, the first is the intercept, or 0.1. And now I want to know for every of this one, 1, 1, 1, 1. As you know, 0 multiplied by any weight, it will be 0. Okay, so if 0 multiplied with any weight, this one, it will be 0. So we can just consider only 1. The first one, it means the word a. Okay, the word a. This one a. Then we will have 1 multiplied by 0.2 with the weight. This is 0, is grid, and then 1. The word is Kim. So the width is 0.8. Okay, we put this one 0.8. And this is 0, 0, 0, 0, 0. So the word here is vary. Okay. So the word vary is 0.1. And then 0, 0, 0, and 1. 1 is the last one, 0.3. So this is 0.3. Then we can get a value of z. So this is the summation. So 0, theta 0 means the intercept plus the total of each of the width and the respective x. And we can get 1.5. After we have this one, then we can calculate it. So the calculation will be something like this. We have 1 divided by 1 plus e, and this is the summation for all of the respective text. And then yeah, we just put this as the z. Okay, we put this as z. So we put this as the value here, and we got the value is 0.8176. Now, as I mentioned to you, this is good for the binary classification. Okay, what is the binary classification? In the binary classification, we have only 2. And based on the probability, we usually have only 1 and 0. So if the probability is nearby 1, then it belongs to class 1. If the probability is nearby 0, then it belongs to class 0. Okay. We already defined that 1 is spot and 0 is not spot. So because it is nearby 1, then we can, yeah, since the value is higher than 0.5 or closer to 1, then it can be classified as spots. So that's how we can interpret the result. Now, yeah, in these two algorithms, the naive Bayes and the logistic regression. In the naive Bayes, we still have some assumption. Yeah, so the assumption means it is independent between features, or yeah, we call it this is naive. But in the logistic regression, there is no strong assumption. So it is based on the weight, or it is based on what is the importance, the feature importance on the respective model. The training time, yeah, it is fast, yeah, because it is just based on the word occurrence. But for the logistic regression, it is moderate because you need to get the optimum weight. Okay? So we need to optimize the weight. The output are the same. It is the class probabilities. So the class probabilities means, yeah, if the probability in spot is higher, then we call this is the class of spot. If the not spot is higher, then it is the class in the not spot. In this class probability, if it is nearby 1, then it is the class 1. If it is the nearby 0, it is the class 0. So the interpretability, it is easy because it is based on the probabilities for the naive Bayes. But for the logistic regression, you know, we can look at the weight for the feature importance. So the higher weight means the more important features. So if you ask, so which one that is better for the machine learning? So we can just look at the naive Bayes. It is simple, fast, and works well with small dataset, or when the feature independent hold. So it is often effective for the text classification. So for the small dataset, it is good. Okay. But you can have another idea with the other algorithm. For example, the logistic regression, it is more flexible and robust, but can require more data and tuning. So tuning means you need to make the optimum width, especially effective when feature independent is not assumed. So if the features are likely have correlation, then you may consider the logistic regression. So some feature independence, because we don't see any, for example, in this case, I don't see any correlation between and crit, and game, okay? And there is no correlation between the and election. But in some cases, maybe we can see some, like in the current states, we know about the Donald Trump. Okay, so there is a high correlation that it is related with the president, or maybe the word former president. So something like this one. So there is a high correlation between words. In this case, yeah, there is no independence. If you use the naive bias, it is all totally independent. If you use naive bias, then they call it all the features should be independent. There is no correlation. But if you use the logistic regression, we can still look at the dependency if we have a lot of text. So that's the meaning by the dependency and independence. And of course, we can do more advanced techniques. In our example, we just calculate the text without text preprocessing. For example, we don't remove the stop words. Do you know stop words? Yeah, we have the. Okay. So we still use this one. Of course, it will make the probability lower. Or we need to lemmatize some words. Okay. So yeah, maybe the current example is not that obvious, but in some other example, you need to do this lemmatization. And you can look at the text representation. Yeah. So yeah, we are just using the bigrams, but you can use the n-grams, trigram, and so on. Or you can use also the unigram, or you can use the TF-IDF to generate the text representation. And you can use also other algorithms, for example, the SVM or neural network, or we can use some pre-trained model and etc. Okay, then I will discuss the Google Colab in separate video. So in this case, we already learned about the text classification definition, text classification use cases, and also we do the algorithms things, and we'll also learn about the text prediction and classification variants. Yep, this is the reference that I used to make this PowerPoint. So I will finish this video and I will do another video to explain about the code in the Google Colab.